Hi everyone, welcome to Tech Tutorials 2K21. So today our topic is pointers in C programming language. So in this concept we are going to discuss about the definition of a pointer and how to declare and initialize a pointer variables in C programming language, and how to represent the pointer variables, means how the memory is allocated, the memory representation, everything we are going to see. And then pointer to pointer or nesting of pointers, and what are the different operations we are performing on pointers concept. And then we'll see how we are going to use arrays with pointers, strings with pointers, and how we can pass pointer as an arguments to function. So this is today's topic. Let's move on to the definition of a pointer. So pointers are the special type of variables which can hold the address of another variable. So why we can say like pointer is a special type of variable? Because when we take an ordinary variable, it can hold the value, whereas the pointer is a type of variable which can hold address instead of value. So because of that, pointer is said to be a special variable. And in C programming language, we can declare a pointer by simply using a symbol asterisk. So simply we can say star symbol before we are proceeding with your variable name. Such variable is said to be a pointer variable. So this asterisk symbol is also known as an indirection pointer, used to dereference a pointer variable. So this is a syntax. Simply we can provide data type and then the pointer variable name along with asterisk symbol. So this is an example for declaring a pointer variable. So suppose if I take my pointer variable of type integer, so which is used to point integer value, right? Your pointer, it may be of a character or double, so which is going to pointer to a particular data type of values. Like we can say you can take a character pointer, it is going to hold the character values. If you can take an integer pointer, it is going to take an integer values to hold. So like that. So your pointer may be of any data type like integer, float or double. And coming to initialization, as like a normal variable, your pointer variable is also initialized. But here normal variable is initialized with value, whereas the pointer variable is going to be initialized with the address of a variable. So because of that, before we are going to initialize a pointer variable, we have to take an ordinary variable first, and then we are going to initialize the address of that ordinary variable to pointer variable. So see here, so star ptr is a pointer variable. So that star representation, that ptr is nothing but it's not an ordinary variable, it's a pointer variable. So here we can see an example int a. So now I have a variable a which is of type integer, and now the address of that variable a can hold by my pointer variable ptr. So simply we can assign like ptr equals to ampersand a. So ampersand is a symbol which is going to represent the address of a particular thing. So this is how we are going to declare and initialize a pointer variable. So now I'll show you the representation. So here the above example what just I am given. So here my ordinary variable name is a, and which is initialized with a value for 100 example. So now this is an address of an ordinary variable like 354546 is an address of my ordinary variable a. So when I am using my pointer variable ptr to hold the address of an ordinary variable, simply like this, ptr equals to ampersand a. So this pointer variable, instead of holding the value, it can hold the address of ordinary variable. So see, the address of ordinary variable is 354546. So that value is held by your pointer variable. So now we can refer the ordinary variable in indirection way. So now this is an address of a pointer variable 45021. It's an address of pointer variable. So this is a representation of a pointer variable. So now the pointer variables is always keep the address of an ordinary variables. So now coming to an advantages of a pointers. So pointers will reduce the code and it improves the performance and it is used to retrieving strings, trees, etc. and used with array structures and functions also. And by using the pointers concept, we can return a multiple values from the function. So as like in a previous topic which I discussed about the functions, so I said from function we can define only one variable. We cannot return multiple variables. So now by using this pointer concept, we can return a multiple variables or multiple values from the function. It is possible. And the another advantages of a pointer is it makes you able to access any memory location in a computer memory. Like we can access any memory location by using this pointer concept. And then we'll see how we are going to access the value of another variable using the pointer variable. So as of now, before this pointer variables, we are work with ordinary variables. Like we are taken simply an ordinary variable and we are assigned with some value, and simply by using the printf statement, we just display the value of an ordinary variables. Now this is a concept. How we are going to access the value of an ordinary variable by using the pointer variable, right? See for example, so here I am given like ordinary variable a. So a is having the value 100. So now by this 100 I can access directly by a variable a, or else I can also access by my pointer variable ptr. So that is a concept here. Accessing of an ordinary variable value by using a pointer variable. So for that we can follow the steps. Like first of all we have to declare an ordinary variable that is of normal variable, and we can initialize with some value, and after that we need to declare a pointer variable with some data type of as the normal variable, and then we initialize a pointer variable with the address of an ordinary variable. Then for accessing the value of a variable by using the asterisk, so it is known as dereference operator. Right. So I'll go with an example. So suppose see for example we have a pointer variable ptr, and we declare an ordinary variable as a, which is of also of type integer, and ptr is being initialized with an address of variable num, and finally getting the value of num using a pointer variable like ptr. So I'll go with a simple example so you can understand this. Now you can see this is a simple program which illustrates how we are going to take an ordinary variable value with a pointer variable. So this is my main function. So x is my ordinary variable which I initialized with a value 10, and y is also an ordinary variable, and here ptr is a pointer variable of type integer, and now the pointer variable is assigned with the address of variable x, and then y is taken as the value of pointer variable. So if I said ptr, it's simply a variable which can hold address. When I say star ptr, now it will be acted as a dereference operator which will give you the value which is pointed by the pointer variable. So see here, I just execute this program in my online editor, so that now you can see what will be the output. So here I am going to execute. So now see, this program will say like the value of x is percentile d, and I directly retrieving from my variable x, and then percentile d is stored at address. So address can be retrieved by percentile u, and then the value is percentile d, which I am retrieving from x, and the address of x I can directly taken from ampersand x. So this is one way how I can get my x value and address of x. And the same I can do by the dereference operator. So ampersand x is the address. Now the dereference address will take the value from this address, and that value is given by this integer. So which is indirectly I am taken value from x. The same thing I can do with my pointer variable star ptr, and here address can taken by ptr variable. I already said ptr is a pointer variable which can hold address. So whereas star ptr is nothing but it's a dereference operator which can give the value, right, which is stored in a pointer variable. So I can retrieve this value by y also, because y is also having the value of x. So it's stored at address percentile and directly taken a value from y, and this value I can get from my ptr, because the pointer ptr can hold the address, right? So now I just execute this program. So now you can see here the value of x is 10, and the 10 is stored at address. So indirectly we are taken the value from same address, but how we are going to take that value is different. Now you can see, so x is 10 I am given, the value of x is 10 by this printf statement, and 10 is stored at address, and the address I am taken from ampersand x. Ampersand is a symbol which is going to take the address of a variable. So it will give ampersand x is 3007396 right? And then I am taking the same x value by dereference operator with an address provided by ampersand x, and the address is taken from ampersand x itself. So it can going to represent the same value from the same address, and the same going to represented by star ptr, which will give you the value of your x, right? Because x can mean star ptr can hold the value of x, and ptr can hold the address of x. So because of that reason, star ptr can give me value as 10, whereas ptr can give me the value as address, right? So this is a simple example how you are going to access an ordinary variable by using pointer variable. So now the concept is chain of pointers. So chain of pointer is nothing but, which we can say like pointer to pointer, like we can have a pointer variable which can hold address of another pointer variable. That is also possible in C programming language. So by a pointer variable we can hold only the address of ordinary variable. Whereas we want to keep an address of pointer variable, we need another pointer variable which is said to be pointer to pointer variable. Like for that we can use two indirection operators. So before the pointer variable name, which makes it as a pointer to pointer variable. And remember, the difference between a pointer variable and pointer to pointer variable is, pointer variable can hold the address of an ordinary variable, whereas the pointer to pointer variable can hold the address of pointer variable. So see, this is an initialization. So data type, we can take a pointer to pointer variable, and which is going to initialized with the address of a pointer variable. So in this example, ptr1 is my pointer to pointer variable and my pointer variable is ptr, right? So now this is of type integer. So now pointer to pointer variable ptr1 is going to keep the address of a pointer variable ptr, whereas the ptr can hold the address of an ordinary variable like int a, suppose. So a is an ordinary variable. Now ptr is having a capability to store the address of an ordinary variable, whereas ptr1 is a pointer to pointer variable which can hold the address of pointer variable. And the representation of pointer to pointer variable is, see for example, here the ordinary variable is v, which is having the value as 50. Whereas star ptr is a pointer variable which can keep the address of an ordinary variable, that is ampersand v, right? Suppose the address of v is 2050, then the star ptr can hold 2050 as an address. Means the ptr can hold 2050 as an address of an ordinary variable. So now the address of the ptr is 4050. Then your ptr1 can hold the address of this ptr variable, that is 4050. So this is an ordinary variable. Now by using this pointer variable and this pointer to pointer variable, so this is a direct representation of this address, whereas this is an indirection representation of an address. Suppose, see for example, in a real-time example, so a person wants an address of some other person. So both are friends. So now this friend 1 is having the address of friend 2. So he can directly go to that address and he can find that person. So whereas the third person, friend 3, is only know the address of friend 2. He doesn't know the address of friend 1. So he can take the help of friend 2, and by using that friend 2, he can get an address of friend 1. So that is an indirection way how you are finding the address. So that is the concept of chaining of pointers or pointers to pointers, and this is a simple example which will illustrate pointers to pointers concept. So I will execute in my online editor. So here it is. Now you can see. So this is my ordinary variable and this is my pointer variable and this is my pointer to pointer variable. So now my ordinary variable address can hold by my pointer variable, whereas my pointer variable address can hold by my pointer to pointer variable. So the value of variable I can return directly by variable itself and by the pointer variable and by using pointer to pointer variable. So this is. So I am going to run this program. So now you can see value of variable is equals to 10 and value of variable using pointer variable, that is a ptr1, is 10, and the value of variable where using pointer to pointer variable, that is ptr2, is 10. So that is indirection representation of the pointer variables. And next concept is pointer operations. So as like a normal variables, we can perform all different operations on pointer variables also. Like we can perform arithmetic operations, relational operations, assignment operations, and then we can perform bitwise, then we can perform increment and decrement operations. So as like a ordinary variable, we can perform all the operations on the pointer variable also. So this is pointer operations which we are going to perform different type of operations like arithmetic operations, like we can perform addition, subtraction, multiplication, division and modulus operation on a pointer variable. Just remember that whenever we are using the pointer variables to do some operations, we are not performing on the address, means the operations we are not doing on addresses, We are performing those operations on the values inside of a pointer variable. So that is the thing we have to remember. So I just execute this program and I then illustrate it this so that you can understand. So here I have an ordinary variables A and B, which is having some values like A equals to some 200, and in future I need to perform division and modulus operations, so that I'm trying to decrease my B value. So 15 I will take, and here I perform, I'm taking two ordinary variables A and B and assign with 215, and I have uh, five variables, right, like addition, subtraction, division, multiplication and modulo. So I'm taking two pointer variables which can hold my address of an ordinary variables. So because we are doing operations on pointer variables, because of that, so I'm taking a pointer variables to store the value of an ordinary variable. So after this, I'm trying to perform all operations like addition, subtraction, multiplication and division. So this ISION, okay, division, and then mod operations. And after completion of that, I am going to print the values by using my printf statements. So here I make copy and paste, the empty places is taken like this. So just a second. Yes. So now this I'm getting from division variable. I can change division. Okay. So I just run this program. So now you can see addition. So the pointer variable, when I'm taking star representation, this PTR underscore A is a pointer variable which can hold address, whereas when I'm using dereference operator, it can hold the value. So by that it will take 200, and by this it will take 15. So like that it will take the other values also. She include std. Yes, okay. This is an extra thing. I'll make it as copyright. Division. Okay. Okay, extra thing is there. So now you can see. So all arithmetic operations are performed by this A and B. After addition, we are get 200 plus 15 is 215. Subtraction is 185. Multiplication is 3000, and division is 13, and modulus operation is 5. So this is the arithmetic operations we can performing on the pointer variables. So then you can also perform like other operations like relational operations we can perform. So see, we know like the relational operations are like comparison operators like less than, greater than, less than or equal, greater equal, equal or not equal, and all these we can say like relational operators. So we can perform the relational operations also on the pointer variables. So I just execute this. So because of gaps we have this problem. So like we have an ordinary variables A and B, and later we have pointer variables PTR underscore A and PTR underscore B. So these can hold the address of A and B, and then now we are going to compare the variables A and B through the pointer variables. So if pointer variable a is less than b, then it is going to print like percentile d, means the value which is taken from a is less than b, or else so this is our if case. So I just copy and paste it because we are getting the problem like it's greater than. So now you can give like greater than, and if I want to find out the equality, then I can give like equal symbol here. Yeah, see here is equal. So if both are equal, then it will print like is equal. So I'm going to run this. So before that I have to close my main function so that I can write return 0. Alright, return 0, and then I can close this. So it will show me like because the if statement is going to executed here. If condition is true, then only I'll give a statement to print. So here the condition is PTR A is less than PTR B, means 20 is less than 10. The condition failed, so this is not printed, like 20 is less than 10 is not printed. And then it is going to check whether the 20 is greater than 10. Yes, the condition is true. Because of this reason, it is going to print 20 is greater than 10. So in this way, we can do the relational operations also on a pointer variables. So we can compare the pointer variables whether it is lesser, greater or equal, like that. So then the next operations are the conditional operators. Like we can apply the conditional operation also on the pointer variable. So we know like pointer variable, the conditional operator is nothing but like it will be acted as if else statement. Simply an if else statement it will acted as. So it is a simple program that illustrate the conditional operators. So like see here I am comparing A and B. So if A is greater than B, then A is my answer or else B is my answer. So whatever the answer it will be, that is going to be assigned to my variable result, and that is going to be printed on this printf statement. So I just simply run this. Before that I just delete this standard output. So now you can see 20 is greater. 20 is the greatest because my aim is to find out which one is greater, right? Which one is greatest. Suppose if I assign changes this value, you can see I'm given a equals to 150. Then it will show you like 150 is greatest because that value is written from pointer variable a. In previous condition, the value is written from pointer variable b because this condition failed and this expression is going to be evaluated. So I just run this program again. You can see the 150 is the greatest, is nothing but the pointer a is going to be executed. So this is how we are going to perform a conditional operation on a pointer variables. And I'll go with one more operations so that illustrate after this. We have an increment and decrement operation. So as like an ordinary variable, and we can also increment or decrement the pointer variables also. So whereas if I incremented the value of a pointed variable, then it is going to be incremented by 1 inside of the value. And if I am going to increment the pointer variable itself, then it is going to be take a scaling factor, and then it is going to increment the address of the pointer variable by the scaling factor given by the pointer. So here is a pointer variable I just applied to my variable value. I just show you. So we know like increment and decrement operators are used to add 1 to the value of a variable, and decrement operator is used to decrease 1 to uh, value of a variable. So here it is an example which will show you before and after increment and decrement operations what the pointer variable is having. So see here, this is my ordinary variable, and this is my pointer variable. So I am assigning address of this ordinary variable to pointer variable, and here the increment operation is going to perform, and before increment the value is taken from a pointer variable, and here it is my pointer operation, pointer increment operation. For this pointer variable I am going to increment by 1. So after increment I am trying to print a value of a. Now we are finding when value is get incremented, and for decrease also the same thing is going to happen. So I am running this program. Okay, so I have an extra this, and now you can see for increment operation, before increment the value of a is 45, and after increment the value of a is 46. So before decrement, so I am using the same variable. So after incrementing whatever the value I have, and that value is going to be taken for a decrement operation. And because of that, before my decrement operation, my variable is 46, whereas after decrement, the value is get decremented, and now it becomes 45. So this is how we are going to apply increment and decrement operation on a pointer variables. So this is about pointer operations. So as like an ordinary variables, we can do all the operations. What we can performing on an ordinary variables, we can do all the operations on the pointer variables also, uh, like this. So then we'll see the concept of arrays and pointers. So how the pointers and arrays it can be connected. So by simply using this concept. So whenever we take a concept of array, simply it is nothing but a collection of similar data items, and they grouped under a single name. So whenever we have an array, so even though we are not using any pointer variable, the starting address of this array can be represented by a pointer variable. Because of that reason, whenever we are going to access the next index of an array, so like we are taken at index 0 and we want to access the index 1. So now the address of that index is going to be incremented by its scaling factor, right? Because we know like integer array, so each and every value can store in 2 address locations because it needs 2 bytes of memory. So whenever we are trying to increment by using this plus plus operator, and we are finding that it is going to take the address of the next value or the starting address of the next value. So what this simply will say is, even though we are not using the pointer variable for arrays, so implicitly the starting address of the array can be held by a pointer variable. So because of that reason, whenever we want to declare an arrays, we don't need to give an indirection symbol before that. Okay, so that is indirectly pointed by a pointer variable. So we can take ampersand x of 0, that is the address of the starting index of an array x. Simply we can take like x plus I, because x is nothing but a pointer variable. because I already said the starting address of array can be held by a pointer variable. Because of that, when simply you can say x, it is nothing but the pointer variable, right? So whenever we have to add the index value, right, simply I am performing arithmetic operation on my pointer variable. So the address is going to be incremented by its scaling factor. So because of that, instead of I'm writing ampersand class of I, here I'm simply written class plus I, right? So which both implies same. So if class plus I is represent uh, the index of class, means the address of that particular index, whereas the star is going to be represented the value in that particular index. So because of that, see, this is a simple example for arrays and pointers concept. So here we can see this is my an ordinary variable which I am using in my for loop, and this is my array name. You can see I am not given any pointer variable here, because I said array itself is a pointer variable, because the starting address of an array can hold by a pointer variable. And here my aim is to find the sum of my array elements, and my array size is 6 and my array name is class here. So initially I'll make my sum equals to 0, and later I'm asking my user to enter array values. So by this scanf statement, in an ordinary way, how we are going to give, here we have to give ampersand class of 0 or ampersand class of I we can take. So instead of ampersand class of I, we can simply take class plus I, because class can having the address of the beginning address of the array class, whereas if I am adding my index value, it is going to give the next address of my array. So now every time I want to add the input value to my sum of variable, so for that here I am using sum equals to sum plus. So the value in this location I can retrieve by an indirection, that is my dereference operator, that is a star. So because of that I am taken like this. So after I am making a summing of all these numbers from my array, I am going to print that variable itself. So I just execute this program in my online editor. So now you can see, so this operator may be my compiler not recognized. Okay, I'll show you both ways so that you can understand that. So I just run this program. Now you can see hash including name. Okay. This is an extra thing I have. So I run this. So it will ask me enter 6 values. So I'll give 6 values, 4, 5 and 6. Now you can see sum is 362. So what I said, instead of giving class plus I, you can give ampersand class of I. Both are same. That's what I'm trying to say. Right? See, this is an ordinary way how we are going to take address of an array. So you can give this or class plus I, both are same. So I just demonstrate this. See here in scanf statement, even though I'm given class plus I or else I'm given ampersand class of I, both will be the same. So I can provide 6 values here and 89. Now it will show me the sum is 282. So this is the array and pointers concept, and we'll move on to the next concept, that is array and strings. Strings and pointers. So by this I will show you how we are going to allocate a memory dynamically. So we all know, like when you take a concept of array is a fixed size. So once you given a size for your array, we cannot alter or we cannot change the size of an array. So whereas a multi-dimensional arrays, when we are using the concept with strings. So if I am given like this, suppose for example, if I am given student of 3 and 25. So what this two-dimensional array will say? So it represents like I have a string student and it's having 3 rows and each and every row is having 25 columns. So totally it will reserve 75 bytes of memory for me. So I doesn't know exactly each and every row will consisting 25 characters. If my first row is having only 10 characters, if my second row is having only 6 characters, if my third row is having only 10 characters, so totally I need only 26 characters of space among of the 75 character space. So all the remaining space is wasted internally. I cannot use that space for the other purposes. So that I need to reserve a memory at runtime. So dynamically I want to store my what we can say like I want to allocate a memory for my strings. So that is possible by using this pointers concept. So the pointers will makes us dynamically allocate a memory for arrays concept. So here I am talking about a strings. Because of that I am taking a character array. And now you can observe that here is a variable name max is of type integer and it is a constant variable. So this is the way how we can declare a constant variable by using const constant keyword. And after that this is my array, that is a string. So my string is a pointer variable. Here you can see I'm using two-dimensional string here because this is the first row I have Gauri and second row I have Devi and third row I have Vizag and fourth row I have Solo. So these are the 4 strings. So I need 4 rows. In each and every row, the first string is need only 5 characters, second string is need only 4 characters and third string is need only 5 characters and fourth string is only need 4 characters. So totally it will reserve 18 characters to me, right? So if I doesn't take a memory dynamically, right? So it will take reserved a memory as a fixed. So much of my memory is wasted internally. I cannot use for other purposes. So I will demonstrate this example. So I just run the same in online editor. Okay, so this is my max which I am using in my for loop. So maximum I can take only 4 rows. So in each and every row, these are the characters will define how many columns I required and that can be assigned dynamically. So now see value of names means the value of 0 at location. The value of names of 0 at location means at first row I have my value Gauri. On second row I have my value Devi and third row I have my value Vizag and fourth row I have my value Solo. So we all know like array index starts from 0 so that it will take names of 0, names of 1, names of 2 and names of 3. So in this way we can reduce the wastage of internal storage and we can allocate memory dynamically by using this pointers concept. So I just run this program. So now you can see the value of the value of names of 0 is my first row which will consisting the string as Gauri. In second row I have string Devi. In third row I have string Vizag. In fourth row I have string Solo. So this is how the strings is going to use with a pointers concept. And the last concept in a pointers is pointers and functions. Means how you are going to pass a pointer as an argument to a function. So in previous concept, like when I am discussing about a functions concept, at the concept of call by reference, I already shown how we are going to pass a pointer variable as an argument to a functions. So by this, Here I am given example how you are going to use the pointers concepts to retrieve multiple values from the function. So I said at the function concept we cannot retrieve more than one value from the function. We can retrieve only one value. So whereas by using this pointers concept, we can retrieve multiple values from the function. So I just demonstrate that thing in this pointers concept with functions in C programming language. So that is the last concept. So functions and pointers. So functions and pointers concept will says that how the pointers is going to be given arguments to our functions. So here my aim is I want to retrieve multiple values from my function. So we all know like main function is said to be a calling function, whereas my sub function is said to be a called function. So from that called function I am going to give multiple values to my calling function. That is a concept here. So whenever we want to take a pointer as an argument to a function, so at the function declaration and definition we have to give a pointer variables, whereas at the time of function calling we have to give an address of the variables. So that's what the difference we have. So here I demonstrate this example.